All right. Well, welcome everyone. My name is Laura with the Plano Public Library, and I want to thank you for joining us for tonight's program. Please note your microphone and video have been turned off. If you have any questions, you can type them into the chat, which is being monitored and is also a location where you can get assisted with any issues and bring questions to my attention. We will also be sure to leave time for questions at the end. Now, I do have a few housekeeping reminders that I do want to share. Please note that this program is being recorded and will be made available on the Plano Public Library YouTube page for later viewing. Soliciting business or selling merchandise during library virtual programs is prohibited. Please show respect for our presenter and one another throughout the program. Zoom provides live captioning. The option is available in the Zoom toolbar. And with that, we'll jump right in. So welcome to Be a Citizen Science, Globe Observer. This is a series of 3 programs, each focusing on a different citizen science opportunity. This week, we're going to talk about Globe Observer. This program is part of our STEAM-tober, which is a month-long celebration of STEAM programming at the Plano Public Library. Our theme has been weather. Now, before we get started, I do want to take a moment to look at what citizen science is. So citizen science is a collaboration between scientists and people who are curious or concerned about the world around them and are motivated to make a difference. It was not until recently that science became an occupation. In the past, science was something done in your leisure time. For example, in 1674, Antony van Leeuwenhoek discovered microorganisms. He was a cloth merchant who made lenses to look at the weaves of fabric. In his free time, he used these lenses, which were much more powerful than the microscopes of the day, to look at pond water. Today, he is known as the father of microbiology. Over time, science moved into the realm of professionals. Citizen science is a continuation of this tradition of the everyday scientist. Anyone can participate. The data collected by citizen scientists help professional scientists come to very real conclusions. Citizen science results in rigorous, reliable, and trusted science. Don't worry about having the expertise that scientists have. People who are not scientists still have skills that are valuable to citizen science. As you work on these projects, your expertise on the topic will grow. You are the expert of your surroundings. You know when something is different or off. This is valuable when you are doing a citizen science project about the world around you. Citizen science projects do rely on experts to validate observations, and multiple citizen scientists review the same things so that a trustworthy consensus is reached. Don't let the fear of being wrong hold you back. So as I mentioned, tonight we will be looking at Globe Observer. This is an international network of citizen scientists and scientists working together to learn more about our shared environment and to track changes in the environment in the support of the Earth system science research. Data collected through Globe Observer is available to scientists and students of all ages doing a variety of different projects. GLOBE stands for Global Learning and Observations to Benefit the Environment. Current observations are focused on clouds, mosquito habitat, land cover, and trees. We'll take a look at all 4, but the bulk of our focus will be on clouds. So we'll start out by talking about creating an account. Now you can create an account using your browser or the app. For today, we are looking at using the app to create an account. The app is free to download and runs on Android or Apple devices. The screenshots you see on your screen now and throughout the rest of the program are taken from an Android device. Now you do need an email address to create your account. So the first thing you're going to do when you open the app is you need to agree to the license application usage agreement before you can do anything else. You will then create an account by clicking on that orange Create an Account button. The next screen will ask which best describes you. It gives you the options of teacher or formal educator, informal educator or volunteer coordinator, citizen science, or STEAM or scientist scientist or STEAM professional, sorry. So for the purpose of today's program, we will select citizen science. For the country you reside in, select the country you reside in, add your email, answer if you are a Globe alumni, and create your password. You'll be prompted to create a username using either the choices in the drop-down menu or by choosing the system created one. Next, you'll be prompted to select a Globe organization. It will default to the country you selected on the previous screen, but you have the option to join a Globe school or organization. Do this only if you are part of a local Globe school or organization. The same applies to the Globe team below that. So for the purposes of what you're doing with this, you're going to use the default and your team will be no team. You will then receive an email asking you to verify your address. And once you've done this, you can start using the app. A few things to keep in mind as you make your observations. Always make sure that you are in a safe place to observe. Don't go onto private land unless you have permissions from the landowner to be there. Each observation type has a multi-step observation process, but not all the steps are required. Those steps that are required involve nothing more than you, your mobile device, and the object of observation. The optional steps may be a bit more involved and require some extra equipment. We'll look at some of these. I will make sure to note which are required and which are optional. Now, before we jump into making observations, I do want to take a moment to look at rewards. As you are collecting your data, you will earn milestone badges. When you receive a milestone badge, you'll be notified by email that you have earned it. And you can see on the far right of the screen, there is a badge for my first mosquito habitat mapper submission. And collecting data for more than 2 days in a row will create a streak, and missing Saturdays and Sundays will not ruin your streak. So this is something that is going to happen with all 4 of the different protocols. Start with the Globe Mosquito Habitat Mapper. So this aspect of the Globe Observer app allows you to document habitats and identify mosquito types. Millions of people die every year from mosquito-borne disease. Scientists can use climate and weather conditions to guess where spikes in mosquito populations may occur, but the only way to be sure is to make observations in real time. This is where citizen scientists come in. By using the Globe Observer app to make highly targeted local ground-based observations, citizen scientists allow researchers to augment their broad-scale satellite-based research to more effectively identify where spikes in mosquito populations occur. So when to observe anytime, even if it isn't quite mosquito season yet, your observations will help give a baseline for seasonal changes. Where can you observe? Always make sure you get permission to look for mosquitoes, and any pool of still water is a potential habitat, as water that is still is what that larva needs to grow. So this can include natural puddles, ditches, trash, and other abandoned items. Larvae have been found growing in bottle caps filled with water, so they can be anywhere. But mosquitoes also play a role in our ecosystem, both as pollinators and food sources for other animals. So it is important that some of them stick around. When you finish your observation, eliminate that mosquito habitat if it was created by human activity, so something artificial, and it is near human habitation. So if it's by where there's people, those are 2 times that you can eliminate the habitat. This will help reduce the threat of disease. But if you're out somewhere, it's far away from people, it's a natural habitat, there is no need to destroy that habitat. So making your observation. Find and photograph a mosquito habitat, then report if you see any mosquito larvae in the water. This is the required step in the observation process. You can see here, we have identified the breeding habitat. So some of the options are a still, pond, ditch, puddle, and so on, flowing. So this is still water found next to a river or stream, an artificial container, a natural container, a larvae or adult trap, among others. And for this observation, I chose a artificial container. And then it's going to ask if it is a water storage container or a discarded trash or other item. Identified the breeding habitat. So there's a couple of options here as well. Grill or outdoor appliance, rain gutter or other architecture feature, public works like a culvert, bridge or road, a pool, flower pot, or refrigerator drainage. And then you want to get a good wide image or view of what you're going to take a picture of. You want to make sure that there is no one in the picture, and then you'll be able to photograph the site. Oh, we'll stay on here for a while longer. And then if you want to make a further observation, which I typically stop here, I haven't mastered the art of mosquito observation yet, you can go a little farther. So you'll get a scoop to get a sample of water. It is recommended that you put that scoop out over something white so that you'll have a good contrast between those mosquito larvae and what they're showing against, like a white plate, a white tray, something like that. And then you're going to count the number of mosquito larvae that you see. Now, the most involved observation is photographing and identifying the species of larvae in the water. And I'm not that great at getting a good close-up picture of something that moves. It's another reason I haven't gotten into this territory yet. But there is a scientific key in the app that will help you to identify the larva. And then you are going to need some sort of magnification to identify them. So either a microscope or a micro lens. Move on to something a little less buggy. Let's look at land cover. Now, land cover is a general term that is used to describe what is on the ground. Land cover can influence the weather, soil properties, and water chemistry. It is the base data set for several areas of critical sciences, such as hazard analysis for floods, fires, landslides, and mapping wildlife habitats. And many smaller spots on Earth aren't going to appear on global satellite maps. Submitting sites through the Land Cover project of Globe Observer can help fill in these local gaps and contribute to consistent and detailed global maps. So let's talk about participating in land cover. When to participate? You can make an observation at any time, but some observations can have more scientific value than others. These include repeat observations of the same location throughout the year and in different seasons, which will help with phenology research, which is the study of seasonal cycles. Observations when big changes happen, like an empty field going through development, or after a natural disaster, like fire or flood. That is not to say you have to wait for something big to happen. You can make your observations anywhere, anytime. But they do work best when they are made in a location that are 50 meters in all directions, observable, or 100 meter by 100 square meter. This is approximately the size of a football field. So the first step in making your land cover observation is to report on surface conditions. Is there snow or ice, standing water? Are there leaves on the trees? And then you will take a picture of the land cover around you. Remember, you will want to select an area that is about 50 meters by 50 meters. Here it did autofill my date and time. And something that I have run into a lot is that the automated option is only available for phones which have a compass or a magnetometer, and mine does not. So I do take the pictures manually. And you can see here, it first had me take a picture right above me, and then immediately at my feet, and then a picture north, east, south, and west. Now, if there are any things you want to add, some notes about it, you can do that before you complete your observation. Globe trees. Now, this is one I'm just going to touch on, and I'll tell you why in a moment. But trees are important. They moisten our air, they fill it with oxygen, and they store carbon. They are the best indicator of an ecosystem's ability to grow trees. And the best indicator of an ecosystem's ability to grow trees are the heights of the trees already present. So this is really looking at the height of trees. By studying the heights of trees, NASA scientists can understand the gain or loss of biomass, which informs their calculations of the carbon that trees and forests take in or release into our atmosphere. And by tracking how trees are changing over time, estimates about the number of trees that make up an area can be made. And I mentioned in the last one, the land cover, that sometimes you need that magnetometer. And this is one where it really wants it. It will not let you really do an accurate reading without it. And my phone does not have one. You can do a Google search to find out if yours does. But we'll talk a little bit about the process without any examples. So you are going to want to do this with a tree that is at least 16 feet tall, and it should be isolated, or at least the tallest tree in a large grouping of trees. You're going to stand 25 to 75 feet away from the tree and make sure you have a clear view of the top and the bottom of the tree. And you can make the observations at any time. If you want to observe a tree's growth over time, do measurements of the same tree every month. Once you've selected your tree, you're going to use the app, as long as you have that magnetometer, to measure the angle between the bottom of the tree and its top. And you can take a picture, this is optional. And then as you walk towards the tree, you're going to count your steps until you reach its base. This will help estimate the distance between you and the tree, and that is a required part of the globe tree observation. You'll be measuring the circumference of the tree's trunk. Again, this part is optional. You will require a tape measure for this. I recommend kind of the soft ones, like the ones that tailors use, not a metal one that will be difficult to wrap around the tree. And then you'll report on the surface condition of the tree, such as snow, standing water, or leaves on the tree. This, again, is a required part of the observation. So now let's jump into what we really came here tonight to talk about, which is clouds. This ties into weather. Clouds reflect, absorb, and scatter sunlight and infrared emissions from Earth, which affects how energy passes through the atmosphere. And different cloud types have different effects. Clouds can change quickly, and frequent observations help to track these changes. These observations record change over time and help with interpreting satellite cloud data. Talk about participating in clouds. Observations, again, can be done at any time. If you notice something different from the norm, like a dust storm, that's also a really good time to make an observation. And they're especially helpful when they're matched to a satellite flyover. And there is a calendar of upcoming flyovers in the app. So if you take a cloud observation 15 minutes before or after the flyover, the matching satellite image will be emailed to you. And I'll show you what that looks like in just a moment. So when you make your observation, it's going to start by autofilling the date and time, as well as the latitude and longitude. And then you will hit next. And it's going to ask you to report on the overall cloud cover percentage. So what percent of the sky is covered with clouds? And if applicable, the sky cover and visibility. And these are both required part of the observation. So you can see there's an option for clouds or contrails, clear sky, there's nothing up there, or obscured. For some reason, you cannot view the sky. You're going to rate just how visible the sky is. On the day that I did this, it was unusually clear. It was just after it had rained. And then you'll talk about the surface conditions. So again, snow, ice, standing water, muddy, leaves on the trees. And then you'll be taking photos. And again, if your phone does not have that magnetometer, it's not going to do it on its own. You'll have to do it manually. So you'll take a picture in each cardinal direction, as well as up and down. So you can see here, I did north, south, east, and west, directly above me, and then directly below me. And I will say it's really weird taking a picture of the ground beneath your feet. They're all going to look very similar to the one I've taken, which is just a grassy patch. And then if there's a special feature, so if something weird's going on, if it's hailing or there's just a really bizarre, unusual cloud, go ahead and take another photo of that feature. And then if you want to add any notes, you can, and then click complete observation. And then it might take it a little while to submit, but then it will get that submitted. Now, if your cloud observation matches satellite data, you will receive an email very similar to this one. There's a lot of data in there, but if you click the Globe Clouds Satellite Comparison, it'll take you to a page that looks like the screenshot in the center. And I took this screenshot off my phone, so it's kind of small, but you can see the blue in the second column of that table. Those are my observations. And then the larger column that is in white is the satellite observations. And you can see I got pretty close. I said there was no cloud cover at 0%. The satellite apparently saw 0.74%. And then the globe cloud photos and corresponding NASA satellite image. This is where you can see the satellite image of the date and time that you took your photo. So I clicked on the visible. The infrared is kind of neat, but the visible makes the most sense. And you can see here, this is what the satellite took a picture of at the same time, or about the same time that I was taking my picture. The neon has been added, so that purple is the Red River, and that little blue dot is where I took my images. So it's really neat to receive this, the nice view of where you are from above. Now let's take a look at clouds. So observing clouds, also known as cloud spotting, can be a fun way to connect with nature. But if you become familiar with clouds and their meanings, you can start to predict the weather. So we're going to look at the most common types of clouds. There are a lot more than this, but these are the ones you will see most frequently. And we'll get started with cumulus clouds. So these are very puffy. They are low in the sky, about 1,200 to 6,500 feet, and they're going to grow vertically. So they'll get taller instead of wider. And they look like cotton balls. They typically form on sunny days, and they indicate fair weather. However, when the tops of the cumulus clouds start to resemble cauliflower, rain showers may occur. Then we're going to go into stratocumulus. These are low in the sky, and they're about 1,200 to 6,500 feet. They're lumpy looking layered clouds that can be patchy, and these are the most common on Earth. So these are the ones we see most frequently. They can be bright white to dark gray in color and can be in rows or spread out across the sky. And they rarely produce rain, but when they do, it's very light. I think it was this weekend, my mom and I were out and the sky started to look like this. And she's like, do you think it's about to storm? And I knew because they're stratocumulus clouds, even if it did rain, we wouldn't be caught in a downpour. Then we have stratus clouds. These are very low clouds. They stay below 1,200 feet and they can look like fog, but they don't quite reach the ground. They are either gray or white. And when you have overcast days where the sun's just not out, but it doesn't rain, these are typically caused by stratus clouds. They can, however, bring a light mist or a drizzle. But again, if you see stratus clouds, you do not need to worry about a downpour or a storm. Altocumulus. These are mid-level clouds that can cover the entire sky. They're at about 7,000 to 18,000 feet, and they're going to be a mix of ice and water, and they consist of little clumps that are referred to as cloudlets. They're typically found in settled weather, but if you see altocumulus clouds on warm, humid mornings, it can indicate thunderstorms brewing in the late afternoon. So if you know that there is a chance of thunderstorms in the afternoon, see if you can go out in the morning and see if these altocumulus clouds are visible. and that can kind of help hone your, oh, storm's about to come, understanding of the sky. Altostratus clouds. Again, these are mid-level clouds, about 6,500 to 20,000 feet, and they are typically gray or blue-gray, and they're spread out of, over very large areas, and they can cause spectacular sunrises and sunsets. They are comprised of layers, and in the thinner spots, the sun or the moon can shine weakly through. And they may indicate that a storm with continuous rain or snow is on its way. And cirrus clouds, these are one of my favorites. They're wispy, feathery looking clouds, and they're made entirely of ice crystals. They are also called mare's tails due to their resemblance to a horse's tail. So you can see that here really well in this area right here. I think they kind of look like an upside down tail, or I guess if this was the horse and there's their tail. So I always think that's a neat part of the cirrus clouds. And they're at 20,000 to 40,000 feet. They're very white in the daytime because they're made entirely of ice crystals, and they're seen during fair weather. Now, if they start to build up and then are followed by cirrostratus clouds, it indicates that a warm front is coming. And a lot of these cloud pictures were taken here in Plano. Some I pulled from like Unsplash and other places that I just couldn't get a good picture of them, but most of them are from here. Cumulus clouds. They're at about 20,000 to 40,000 feet, and they're a patchy cloud resembling ripples or a honeycomb, and they're about the size of your little finger when held at arm's length. So if you put your arm out and hold up your little finger, each of the little clouds should be about the size of the tip of your finger. And they're common in winter, and they indicate a fair but cold weather day. So no rain, no precipitation comes with these clouds, but it's usually pretty cold. Then cirrostratus clouds. These are high transparent clouds at 20,000 to 40,000 feet. They cover huge areas of the sky, and they're easy to miss. They typically appear 12 to 24 hours before rain or snow. And there's two types. There's the cirrostratus nebulous or nebulosus, and these resemble a veil, or they're almost unnoticeable, just looks like a hazy sky. This indicates that a warm front is on the way, typically bringing persistent rain. Now, if they look like wispy strands of hair, they are cirrostratus vibratos. They are going to have only light drizzle. And then let's talk about nimbostratus clouds. These are dark layers of cloud that resemble a blanket. They can cover so much of the sky that the edges are not visible. They're at 20,000 to 10,000 feet, and they produce persistent rain or snow, depending on the time of the year. So these aren't necessarily storm clouds, but they are going to bring a lot of rain. And for our storm clouds, cumulonimbus. Now the base, so the very bottom of this cloud, is about 6,500 feet in the sky. However, the top can reach up to 10,000 to 50,000 feet. Now, as it reaches 10,000 feet, high winds will flatten that cloud's top so it looks like an anvil shape. And these are storm clouds. They can bring heavy rain, hail, lightning, and tornadoes. We start to really see these in August and September around here. They don't always produce rain. A lot of times they will fall flat, but you'll see a lot of them. I do love the sky in August. Let's look at some features. We've met the most common clouds in our skies, but these are some features you might encounter. So a virga. These are clouds that are raining or snowing, but the precipitation evaporates before it can hit the ground. So they're going to look like jellyfish with tentacles hanging down. That's the precipitation. You're seeing it. It just does not reach the ground. the air it is falling through is either very warm or very dry, and it just evaporates before it reaches the ground. Now, precipitatio is very similar to Virga, but they have that visible precipitation, but it's reaching the ground. And these are ones that I see fairly recently here, often around here, because we're a nice flat prairie. You can see pretty far. And so it might be raining a ways away and you can see it. To asperitas, these look like waves in the sky. They are the underside of the cloud, and they occur with stratocumulus or altocumulus clouds. And then another really neat one is the cavum. This is a circular hole in the middle of some clouds. It can be caused by a virga, which that precipitation goes through, evaporates before it hits the ground, or even an aircraft flying in the sky. So if you ever see a perfect circular hole in the cloud cover above you, it's not a sky crop circle, it's a natural phenomenon. All right, well, before we talk about what's next, do y'all have any questions for me? All right, well, if you think of some in the meantime, you can always submit it through our Ask PPL option on our website. And whoever is keeping an eye on that will see that it is citizen science related and make sure it gets back to me. So what is next? Go out and make your observations. You can use your own backyard or one of a park in Plano. We have over 85 parks and 98 miles of trail. You can see in the picture there, that is Arbor Hills on the top and then Oak Point Nature Preserve on the bottom. Those are great places to go do citizen science, but any outside area, as long as it's safe and not private property, is a great place to observe. Now, if you want to hone your cloud spotting skills, we do have a brand new STEAM kit for adults that is available for checkout or holds, and it is about cloud spotting. So there are some flashcards to help you get used to recognizing clouds, as well as some books and a nice little viewer that will help you ID clouds in real time. And then we do have two upcoming programs. The first is iNaturalist on November 24th. It is at 6:30, just like this one. And iNaturalist is an app. It's going to focus on the plant and animal life around you. And then December 22nd at 6:30, we have our final fall installment of Be a Citizen Scientist, and that is going to be over eBird, which is about birds. We look forward to seeing you there. And if we have any other questions, go ahead and thank you so very much for joining us this evening. Please be sure to stay up to date with the Plano Public Library by following our Facebook page and Instagram account. You can find recordings of past programs on our YouTube channel. Please complete our program survey, which should pop up following this program. We do value your feedback. Thanks again for joining us today, and we will see you next time.